So good morning, everybody, and I hope that it's not too late for you in Asia. I will make a presentation here, which is a presentation about rotating propellers and Vstols. And for practical issues, I will go through the presentation, and then in the end, there will be some time for questions and answers. So if you have any questions, it's probably better that you just write them down and then take them in the end of the presentation. The presentation will take roughly half an hour, and then it will be some time for asking questions. So first of all, I would like to let me see if I can change picture here. Well, so the first slide here is showing that this is for propeller rotorcraft and actually for drones and for all kinds of flying objects that are using a vertical or short takeoff and landing. So let's continue. So what will you learn during this session? Well, we will talk about the different disciplines within traditional aerospace acoustic testing. We will talk specifically on the source of noise in propeller, rotorcraft, and vertical or short takeoff and landing vehicles. We will talk quite a bit about new challenges, which is on-demand aviation and also on drones. And then I will show some products that can be used in this segment. So this is the agenda for today. I have some challenges in taking the next slide here. Here we are. So myself, some of you know me already, but for those of you who don't knowing me, I'm Lars Wimberg. I've been working for GRAS for roughly a year, and I have a military background, and I have also worked in the sound and vibration business for more than 20 years. So that's a little bit about myself. First, I would like to show you a slide here, and this is a European slide, but it is actually widely used also in US and also in Asia. ACARE, it's a group which is called the Advisory Council of Aeronautic Research in Europe. And this group, it is a group of people, and that is people who's in charge of legislation as well as in the aviation industry. And they have agreed upon that they need to reduce the noise from traditional aircrafts with 65% until 2050. If they don't do that, there will be political pressure to actually have less airplanes in the air. So they have basically started a number of projects that is all trying to reduce the noise from aircraft. And when I'm talking about aircrafts, it is all type of aircrafts, meaning everything from commercial airplanes to helicopters to everything in the air flying. So how are they going to do that? Well, first of all, they have noise reduction of engine and airframe. That is for the manufacturers to actually make less noisy constructions. Then another issue, another topic that they are focusing upon, it is the environmentally friendly flight procedures. So if you can spare a number of densely populated areas for air noise, then it is better, of course. So they work with flight procedures. They are also having a number of projects for electrical engines, for putting that into airplanes. So that will be the same sort of development as we have seen in the car industry, going from fossil, petroleum and so on, and over to electric engines. And then, of course, all kinds of new technologies that may be available within the next 20 years. So all that together, they are hoping, crossing their fingers, that they will achieve a noise reduction of aircraft for 65%. So this is a very, very big driver for actually driving down the noise levels in the aviation industry. Problem is a little bit that an airplane sold today or purchased today, that will be phased out in 2050. So that means that the technology that we are having today will be still in the air for the next 40 years, or 30 years at least. So that's a challenge. Great. So the traditional aerospace applications, and this is why we are actually doing measurements on airplane and aviation. It is, first of all, they have a very sharp certification of aircrafts, and that is called the ICAO Annex 16. This is an international certification of aircrafts for noise levels. So if a new aircraft that is manufactured cannot pass the certification of the Annex 16, that will make the aircraft impossible to sell to clients. So this is really, really a make it or break it test for all the aircraft industry. And that goes for helicopters, that goes for propeller engines, that goes for commercial airlines. Then, of course, why do we do measurements? Well, as we saw before, environmental protection is actually a very hot topic. So even if we can pass the certification test, then we still have to keep in mind that people are living around the airports. They need to be sort of protected. Then it is passenger satisfaction. Everybody has been flying on an airplane where it has been noisy. And you don't really like that. If it is quiet in the cabin, it's a much, much more pleasant situation. And therefore, a lot of airline or at least aircraft manufacturers, they are really, really pushing the limits for noise in the cabin. Then we have fuel efficiency. If an airplane is less noisy, then per definition, it will take less fuel and it will be more fuel efficient. So that is also a very big driver in the aviation industry. Then, of course, it is also what we call the acoustic fatigue. That is the life of an aircraft. If it is too high noise levels, that will make mechanical fatigue on parts on the aircraft, and the aircraft will last less. So the traditional aerospace applications, you can divide that into 4 pieces, and the first one, it is all different kinds of disciplines within jet engine measurements. And that is, for example, jet aeroacoustics, duct acoustics, turbomachinery and core noise acoustics. And if you go to LinkedIn and you search for some of the keywords here, you will find specialists in the different fields. Second one, it is if the plane is not driven by jet engines, then it might be propellers or Rotorcraft or Vstol, which is vertical short takeoff and landing. And then it is everything in a combination. So this means that this is the airframe and a lot of disciplines within airframe monitoring. And that could be for the landing gear, that could be for flaps, that could be for the wings, and so on and so forth. And then the last piece here, it is the environmental or community noise part. And that is where we are coming into airport noise monitoring and so on. and also sonic boom monitoring or measuring. So the 4 different disciplines or areas, it is jet engines, it is rotating engines, and then it is and then it is all airframe, and then you have the last one, the environmental part of it. So what we are focusing on in this presentation, it is the helicopter and drone testing. So this is the area where we are putting efforts in today. So when talking about Vstol, and this picture is not 100% correct because propellers, they are definitely not vertical or short takeoff and landing vehicles. So apart from that, if you take a look at helicopter, on-demand aviation, and drones, that is where we have vehicles that are taking off almost vertical or with a very short takeoff and landing. So what is the topic here? It is that for helicopter and propeller engines, there is a lot of legislation in place for this area. So there's already developed a number of legal framework for this area. When it comes to on-demand aviation and when it comes to drones or UAVs, there are limited legislation or it is local legislations. So there we have a little bit of an issue. So for the propeller business, there we have companies like Airmaster Propellers in New Zealand. It's the Airscrew company in UK, AKS incorporated in the United States. And this market here for propellers, it is almost all countries, they have some kind of a small local business that is making propellers. And they can make propellers for airplanes, but also for drones or smaller vehicles. When it comes to helicopters, well, all the traditional helicopter manufacturers, there are Bell helicopters, Airbus helicopters, Leonardo, it is Sikorsky, and so on and so forth. So these are the guys we already know, and they are the big ones. Newer, it is, for example, on demand aviation, where we have companies today, for example, Uber, and they have a new company called Uber Elevate, and I will talk a little bit about that later on. There's a German company called Lilium that are also making on-demand aviation. And I will show you what that means more in detail later on. Then we have the drone market. And drones, these guys here, it is, for example, DHL, the usual delivery of packages. They see this as a possibility to deliver faster and cheaper. Amazon, Google, DJI, or Daijang Innovation from China, for example. These are drone companies that might be potential customers to us. So then we also have military drones, and that could be larger vehicles or it could be smaller drones. If we take to look at the traditional applications, the helicopter-related applications. If you take a helicopter and see where is actually the noise coming from and what is the characteristic of the noise. If you take, for example, the most significant noise source, it is the main rotor. And the main rotor, it is when it is rotating, making a noise which is low frequency and high levels. And I marked that out on the picture down there, the red part of it, that's the main rotor, and it is very low in frequency. Then the second part, it is the tail rotor noise, and that is a higher frequency and a little bit less noise from that. And then it is engine and transmission noise. So that could be the gearbox noise or jet engine noise coming from the engines. So all in all, a frequency curve which is highest level on the lower frequencies, usually, and then it is going down over frequency. If we are just taking a look at our microphones, and from a theoretic point of view, this is a 1-inch microphone with some frequency range and dynamic range. So this is a typical 1-inch, and then if you take a typical 1/2 inch, typical 1/4 of an inch, and typical 1/8 of an inch. So when it is smaller microphones, it goes up in frequencies and also typically also go higher up in dynamic range. If you put in the curve of measured noise from a Bell helicopter on the ground, so this is a on the ground helicopter, a Bell helicopter hovering just over the ground level. And here you can see almost the same picture as we saw before. You have a curve where you see the main rotor, which is in the beginning. You see the tail rotor on a higher frequency, around 1000 hertz. And then you see the engine and transmission noise in between here. So what microphone should you choose for a typical helicopter measurement? Well, the most popular microphone that we sell into this area, it is actually a 46 BD. And I have marked out the area where this is having their limitation. I mean, 4 to 70 kilohertz, 44 to 166 decibel. So this will be a very general purpose microphone that can be used for helicopter measurements in all different respects. Sometimes when you have helicopters, you actually do wind tunnel testing with a helicopter. And if you do wind tunnel testing, what you should keep in mind there, it is that dependent on the size of the model, the frequency you are expecting is actually increasing. So this is, if you have a scaled model in a wind tunnel that is half size, then you will expect the frequency to be multiplied by 2. So if the peak for the tail rotor noise is at 1000 hertz, in a scale model where it is half size, then it is 2000 hertz, and so on. So this is a good guideline for having a discussion with a client with this traditional sort of helicopter measurements. Great. If we just go to the next step and take a look at the drones market. I have taken some American numbers here, and these are American numbers, but then you can probably go to your own country and find a very similar statistics. So FAA, that's the Federal Aviation Authority in US, they predict 7 million drones by 2020 in USA. They expect end of this year to have 600,000 commercial drones in the air. They also estimate the value of the drone market today to be $3.3 billion, and the size within 2 years, it's 13 billion US dollars. In 2025, that is only 7 years ahead of us right now. They expect the market size to be $90 billion. So the growth rate in this area, it's extremely big. And what it is used for, well, this is, for example, delivery of packages, DHL, for example, medic services, that could be equipment for helping people that are having heart attacks, for example, to very quickly go out with the kits. Real estate, where they would like to photograph the house or property. That could be traffic control, and you probably have a number of other possibilities in your mind. So the drone industry is growing extremely fast right now. So what is a UAV or a drone? Well, that could be many different things. The first picture you have up there, Black Peak Engineering, the SA-200 Vstol, that's actually a military unmanned helicopter that can transport injured people. So if they have a battlefield where they have difficulties in actually collecting injured soldiers, they can actually fly out with a Vstol, and then they can land, they can collect the injured person and then go back again. The smaller one, the NASA one, that's a octocopter, and that is used for photographing, for smaller topics and so on. And the lower part, it's actually a helicopter, an unmanned helicopter for transportation of people. And that could be one possible solution for the Uber company, for example. What is a little bit an issue right now, it is that with all the numbers of extra UAVs coming, there will be a lot of traffic over cities. So there is a number of legislation that is not in place yet in order to widely spread out drones. So one of the issues they have experienced by testing, it is that drones are more annoying than car noise. So if you just measure the noise levels, it's actually not enough and apply the same legislation as car industry or cars in the city. It is actually, on the psychoacoustic point of view, the noise are different, and people are more annoyed by noise from drones than from cars. So what we see it is that international standards today are missing for noise limitations of drones. Then secondly, if you take military drones, they work very, very heavily on making stealth drones. So they are not discovered by enemy when they are taking photographs or making films or whatever. So they have a huge research in making them less noisy. So this is what I'm talking about, on-demand aviation. And this picture here is taken from Uber white paper, where they are pointing out areas where they have barriers right now. But the idea it is that they have what they call veriports on top of buildings. They have landing fields for small helicopters, and you have an app on your mobile phone, and then you can basically just order a transportation from one point to the other, like a Uber today. And then it will be an unmanned vehicle, flying vehicle, that will take you from one place to another. What they point out as barriers, it is an international certification process, and what is interesting for us, the aircraft noise issue. Because if a lot of Vstol vehicles will fly in over cities, this is an issue. They need to have some kind of a noise certification, and they need to have noise monitoring around the veriports. So this is an opportunity for us in the future to be a part of this, and I will show you some possibilities later on. The hand having the telephone with an app, it is actually from a German company called Lilium, and they have similar ideas of on-demand aviation. So this is an area where we probably see some development over the next 5-10 years. Then, as I said before, psychoacoustic research is being done right now, because it seems like it is more annoying to hear noise from drones than from anything else. What is also an issue, it is if you take a look at the article down to the right, it is saying unmanned aircraft in the national parks. People, private persons, they feel that it's a hobby to go out with the drones and make films or movies or even take still pictures over national reserves or national parks. And is it something that you would like to have when you're out in the nature? It is peace and no noise. And even if it is only just a drone, if you have many of them and if you have them all the time, it's starting to be extremely irritating. So people like this park here has actually banned all drones over the national park. And this is also coming more and more. And if you ban something, you will have to have some kind of measurement or detection of where they are. So there's also a new market coming up for noise monitoring. Great. So the markets to address, it is the existing market, that is traditional propeller manufacturers, traditional engine manufacturers like Turbomeca, GE, etc. Airframe manufacturer, Airbus, Bell Helicopters, AgustaWestland, which is today Leonardo. But anyway, this is the traditional, the typical users of noise monitoring equipment or microphones or acquisition systems. Then you have a growing market for military market. And these companies are, for example, AeroVironment, it's Boeing, Lockheed Martin, Northrop Grumman, Corporation, Thales. It could be Saab, could be Black Peak Engineering. So it's a little bit of new players in the market where you probably have some opportunities for selling microphones. And when you look at the company names here, they are huge companies, most of them, and they have many subsidiaries around. But if you take a company like Thales, for example, Thales, it's a French company with offices all around. Where do they make the drones? Well, not in France. They make drones in different places, and one place it is Spain. And they're also making it in other places as well. So even though there are large corporations with headquarters overseas, I'm quite sure that there might be manufacturing, even research and development in some of the areas that you are located in. Then we have the new commercial market, and that is where we need a lot of legislation. And I will show you NASA is working on some legislations today. FAA, Federal Aviation Authority, ICAO, that's the International Civil Aviation Organization. JAXA in Japan is working on this. DLR in Germany is working on this, and so on and so forth. So there's a number of bodies that are working with legislation and measurement and take all the background data for actually developing the legislation. These are customers to us, or potential customers to us. Then we have drone manufacturers. That is, for example, the German company Lilium. That is the drone that you see on top of that box. Then we have Uber. We have DHL, we have Amazon, we have Google, we have GoPro, we have DJI, Daijang Innovations, and this is a Chinese company, DJI, Daijing Innovations, and they make 70% of all the drones in the market today. So they're market leader on commercial drones. If you take a company like Google, Google is also a huge company, and they do a lot of flight testing with drones, and they have put up all the testing of drones to Australia. So that is in your area in Asia. So there might be some possibility to actually access the market for drone testing. Great. What you should also keep in mind that this new commercial market, it is a predicted market growth of 50% per year up to 2025. So it's a huge growing area. So I would definitely, in your area, take a look on the net to see if you have any drone manufacturers or anyone, consultancy or so, working with legislation around the area, because there will be a lot of work being going on from now on and later on. I went into to LinkedIn, and if you use that, you can do a lot of searches there. And I found this person, for example, he's working for GoPro, and he's an acoustical design and test manager. And definitely he's one of the persons who's responsible for testing their drones and drone operations. I also found this person here. This is a NASA person, and he's working with what it says here, vertical lift hybrid autonomous aeronautical systems, evaluating acoustic perception and annoyance of drones, aircraft, and small quadrocopters, for example. Psychoacoustic evaluations. So these are the guys that we would like to get hold of and try to introduce to grass microphones. Great. So what sort of tests are they doing? Well, on the picture here, the photograph, you can see a drone and you can see a microphone array. So all kinds of beamforming, noise source location, even low noise measurements, and that is primarily on military drones. Then you can expect that they are looking into flyover tests, like with a 67 AX, as you see on the bottom picture here, and then psychoacoustic testing, and that could be a 40 AQ, for example. And as I have given some examples from the internet on the right-hand side, you can see there is a number of companies that are focusing on designing low noise propellers and so on for unmanned aerial vehicles. So there's a number of possibilities to actually access this market, even in your countries. So what is controlling the basis today? Well, I said that we are lacking standards. New legislation is required, but what is controlling it today? It is actually the old standards that you probably know all about. It is the ANSI, it's SAE, it's IEC standards, it's ISO standards, it's Federal Aviation, and it is ICAO, which is International Civil Aviation Organization. All this is already in place, but we need new legislation which is global and that can cover for all the new stuff that is coming out. So what do we sell into this segment? Well, I've taken a statistic from our database and I've said, okay, what is the most popular products within the aerospace area? And I put a red sort of line around some of the products here, which is products that usually can be used for all kinds of drones tests, helicopter tests, and that is the 46BD, which is the most popular into this segment. That was the one I showed you on the helicopter measurements previously. We have the 46AO and we have the 46BE. And then we have the flush mount and we have the ground array, the 67AX. And then for some wind tunnel testing, which is probably not that important for helicopters, could be for drones. Then of course we have the surface microphone. So these are the most selling products into this field. And maybe you will get some ideas what you can actually offer to the market. Last, I would like to give you just an example what we have done together with NASA in order to enhance some of the systems that they are having. You have probably seen the product that you see on the left-hand side down in the corner. That is the 67AX, and this is used for as a ground array and type test applications for flyover tests. So the standard today, it is talking about FAA Annex 16 or ICAO Annex 16. It's the same standard. That is an environmental protection standard, and it is talking about noise monitoring, where you will have to have a microphone that is upside down mounted with a plate. And this plate should then be on a very specific size. And it will be white painted, and it should be 40 centimeters in diameter and at least 2.5 millimeters thick. So this test, it is defined in the Environmental Protection Act, the Annex 16. And Annex 16, if you remember, I told in the beginning, this is one of the most important standards for aviation industry because this is the make it or break it test for new aircraft. So this is many times referred to, and therefore it's very important standard. When testing drones, for example, you still use a lot of stuff from this environmental protection standard because they have a lot of examples on how to do different flyover tests and so on. So this is the traditional way of mounting the microphone according to the standard. Problem is that the traditional method using the inverted microphone, it is giving some difficulties because the microphone position is critical, and therefore you have to do a lot of measurements where to put them. It's cumbersome calibration for an upside down microphone. Sometimes the small tripod is displaced or tipped over by wind, for example, and sensitivity to rain and showers is quite bad. So NASA have, in cooperation with GRAS, done a number of research for a better way to do these kind of measurements. And with our flush-mounted microphone, which is the 47AX microphone, we have done this pizza plate or a cylindric or a circular plate where you do the measurements. So you have the 47AX inside. You have integrated preamplifier. It's 12.5 millivolt per Pascal sensitivity. You have a windscreen that you can remove, and you have a ground plate integration. So you don't have to worry about the ground conditions because you just put out the plate and then it is creating the ground plate itself. What is also good, it is that you have a possibility for calibration easy on this one. And what is happening right now, it is that NASA have bought more than 60 pieces of it, and they have done a number of comparison tests with the upside down microphone, and they are just in the process of getting it certified to be an alternative or a replacement of the old method. So the 67AX, it's a unique product. It is not seen at other manufacturers, and this will be a standard microphone for flyover test and certification in the future. So when is it going to be certified as an accepted solution? Well, we believe that this will happen within the next 3 to 4 months, we have a NASA meeting coming up here in April, where this product will be discussed, and then it will be probably going further into the legislation work. So this is a unique product that we are working on for this area. So now I have probably taken my half hour, a little bit more than that. And just to wrap up, first of all, we have all the microphone requires for measurements in the traditional Vstol segment. That is for helicopter, propeller business, and so on. That is our standard range of products. Then there is a new fast-growing business opportunity with new players arising in the drone market. That means that you have to go out to new customers. You have to find the companies in your countries that are working with these new technologies and drones. Because even if they say that they might not be interested right now, when it is an international standard available for noise from drones, they will have to apply to the standards. So all of them will have to do noise-related work in the future if they would like to sell into the international market. I'm quite convinced about that. And then grass, it's definitely the right partner for this segment. We are working in the new area. We have the products for this area. So there is no doubt that we will be a part of this business. If you have opportunities in this area, we will definitely guide you to the right choice. So if you are visiting a customer like this and you are a little bit in doubt what you need or so, or if there are some research work that will have to be done and you would like to be more able to guide them, we are always here in Denmark and we can help. Per has been working with NASA very heavily, so he will be a resource in this area, definitely. So that was a wrap up of what we have talked about, and now I would like to let you have, if you have any questions about the presentation or the market or the area or what to do. So please open your microphones and give me the questions if you have any.
Hello?
Yes, hello.
This is Kaneda speaking from Marubun Corporation in Japan.
Yeah. Hello.
Hi. Thank you very much for very interesting presentation.
Yeah.
So actually, we are very interested in the drone market.
Yeah.
So I would like to know how to measure the noise for the drone. For example, so some drone manufacturer installed some glass microphone to the actual drone. So I would like to know how to install the microphone to the drone frame.
So you actually have a flying microphone. So you put it on the frame of the drone, right?
Yes.
Okay. How big is the drone?
So just a moment, please. So how did you work? So yes, you showed there some picture of a drone.
Yep.
So
yeah.
Yes, maybe so. Our main customer is Yamaha in Japan. So
okay.
When we promote your microphone to the customer, so maybe customer ask to us about how to install the microphone, how to measure, how about our data acquisition system. So maybe customer ask to the actual how to measure the noise about the drone.
Okay.
And the outright. Yeah.
What I have in mind it is that because this area is so big, I'm going to make some some documents where I'm going to describe more in detail what sort of testing can be done on drones.
Okay. Mm-hmm.
So
okay.
I will distribute that later on, because this is really a growing area. So there will be the tests that typical are done on drones today. It is flyover testing, where they have a number of microphones on the ground, and there they can do different methods. They can have a tripod, an ordinary tripod, and standard microphones, or they can follow the standard to do this upside down microphone, or they can do this ground plate that we're having, the 67AX. That is for the flyover tests. Then if we talk about psychoacoustic testing, that is, much more research oriented, where they are doing tests by having passed by cars and passed by drones, and then do the human interaction of what is best and so on. What is the experience from people? And that is typically done by just a tripod, and then you do the measurements. Then, of course, it is also a business where they would like to sort of design the best propeller, for example. What is the noise impact if they're using a quad helicopter or a quadruple helicopter? Can they distribute the noise or the impact, the environmental impact by doing that? What is the sort of propeller they need to design? So there's a lot of research work in this as well. I think everybody has heard a drone, and they are hissing, they are not having a very pleasant noise. So what I'm going to do some documents within the next week or two, where you have some examples on setup for measuring drones. Then, of course, what I have been thinking about also, it is that for this certification and for noise regulation for drones, maybe there will be some microphones on the drone when it is flying. And that is also a possibility with some products from us, but that is, of course, for a little bit larger drones. So I will distribute the document that I was talking about with some ideas what to do, measurements, and also with some possible acquisition systems. So I will do that within the next couple of weeks, or 1 or 2 weeks. So then and then I will also do a short list of drone companies, big ones and a little bit smaller ones. It's quite easy to make a search on the internet to get a list of let's say the 50 biggest drone companies. And then I will distribute that to our distributors in order to have some ideas where to go to. Great. Is that okay?
Okay, thank you very much.
Thanks. And I have a question here on the chat here, which is the 46 BD, what sort of advantages we have compared to competitors with this one. And I will also, together with the material that I will send out after the meeting here, I will give you some details about that, who our competitors are, and if we have any unique selling points or so for this one. So I will come up with that. Any other issues or questions? Great. Then I will keep in touch with you. I will send you the presentation later on today, and I will make this document within the next couple of weeks. And then hopefully you will have some possible customers within your area for this area. It's an interesting area. Thank you very much, and have a nice Easter when you are coming to that point. Thank you very much, and bye-bye.
Thank you very much.
Thank you very much.
Thanks.